The concept of permutation comes up very naturally when you're talking about the multiplication rule. And what is a permutation? In math, we say that a permutation of a set of objects is just ordering the objects in a row. And so in this particular case, the objects can be written in any order you want, but they cannot be repeated. So like for example, when I chose the president and treasurer and secretary, I was just basically making a permutation. Okay, that's what we did on the previous example over here. Okay, so I was just making different permutations. So you can see the letter was not repeated. C was secretary, B was president, A was treasurer. We didn't have the C repeating twice or the A repeating twice or something like that. Okay, so how many possible permutations can there be in a set with n elements? So the rule is, if you have n elements or n integers or n people to move around, how many possible permutations can you have? It's n factorial. Okay, so that's pretty much straightforward. Let's go ahead and practice an example. It says, how many ways can the letters in the word computer be arranged in a row? So what I want to point out before we start in this problem is that later on we're going to learn about combinations. And so on a test, how do you know that you're dealing with a permutation or a combination? They're both very similar mathematically speaking. The difference between the two is, in the world of combinations, you can have repeats. So if you look at the word computer right now, none of the letters are repeating. So in the word computer, there are no repeats. None of the letters repeat. And also, how many letters are there in that word? So there's 1, 2, 3, 4, 5, 6, 7, 8 letters in total. There are 8 total letters. So what am I being asked? I'm being asked to rearrange the letters. So like for example, I can probably choose C first, M, O, P, U, T, E, R. That could be a possible answer. Or I could say C, O, M, P, T, E, and then R, U. That's another possible one. And so on and so forth. How many different words like that can I make? They don't have to make sense. I'm asking how many words can we possibly make, okay? And it turns out that since there are 8 letters, then there are 8 factorial different ways. So the total is roughly 40,000 possible words can be made. What's another way of looking at this problem? Here's another possible way of looking at the problem. So remember, you have 8 letters. So 1, 2, 3, 4, 5, 6, 7, 8 letters. And you're supposed to put either C or O or M or so on and so forth. So let's say you put C. How many ways can there for the first letter? There are 8 letters in total. So let's say you chose C. Now, what about the second letter? Well, since you already use C, you can no longer use it. So now you have to put, let's say, M. There were 7 choices for you, but you chose M. Now M is no longer available, C is no longer available. So now you want to pick the second number or the third number, or the third letter. So let's say you pick, I don't know how many choices you have. You have 6. Let's say you put T in there. So T is gone. You can no longer use it. And continue doing the same way, the 5, 4, 3, 2, 1. And at the end, you're supposed to multiply this because of the multiplication rule. So 8 times 7 times 6 times 4, and so on and so forth. That's another way of saying 8 factorial, basically. So that's the real reason why the answer is 8 factorial. Okay, so that's pretty much how that's going to work. Now suppose in part 2 that we want to do the same thing again, except this time we want the letters CO to remain together in that order as a unit. So what I'm going to do to answer this question is basically think of CO as one possible character. So I'm going to write down in the word co, M-P-U-T-E-R, there are 7 letters now, because I'm thinking of CO as being one new letter, and none of the letters are repeating. So first I'm going to say none of the letters in the word are repeating, and there are 7 quote-unquote letters in total. So remember, these are not letters. CO is technically 2 different letters, but I'm thinking of it as one character. So maybe a better word instead of the word letters is to say the word character, okay? But in any case, how many choices are there? Well, 7 factorial. So that's roughly speaking 5,000 possible words. And so you can see the amount went down tremendously just by losing one of the letters, right? Remember, that's because now you have less available letters. So if you think about it this time, there are 1, 2, 3, 4, 5, 6, 7 letters. And when you choose the first one, you've got 7 choices, either CO or M, P, U, T, E, or R. So there are 7 ways of choosing that first letter. And let's say you pick, I don't know, let's say M. Then the next letter has to be chosen. There are 6 remaining letters because M is now gone. So let's say you pick CO. They must remain together, so you have to choose C and O in that order. You cannot choose them in any other order. So the next one is going to be 5, then 4, 3, 2, and finally 1. So with that in mind, you can come up with a word, for example, like, such as this one, okay? So that's basically the reason why you are getting 7 factorial. Okay, so the final question is, if the letters of the word computer are randomly arranged in a row, what's the probability that the letters CO remain next to each other in order as a unit? So, well, basically the question is, what's the probability that a chosen word has CO together? Okay, so the total is gonna be how many possible words there are in this universe, and regardless of what letter is first and whatever, we had 8 factorial different words, and how many words have CO together in that order? Well, that's 7 factorial. So the answer is basically 1 out of 8. And so in decimal form, this will be 0.125, or in other terms, roughly speaking, 12.5%. Okay, so there are 12% of the words where the letters CO are in that order next to one another.